Okay, Wildcats. Today we're looking at Wednesday, February 21st, graphing rational functions on page 57. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, graphing rational functions, page 57, and there's no part in here. All right, graphing rational function steps. Step 1, factor the expression. Step 2, identify the holes. Step 3, find the vertical asymptotes by setting the denominator equal to 0 and solving for x. Step 4, find the horizontal asymptotes or the slant asymptotes by using long division. Step 5, find the x-intercepts, zeros, by setting the numerator equal to 0 and solving for x. Step 6, graph the above information. Step 7, graph the critical points. All right, so if you would, update your notes. All right, now your notes are updated. Let's take a look at the examples. All right, example number 1. Find the zeros, vertical asymptotes, horizontal asymptotes, and holes, then graph the rational function. All right, so first, step 1 is you want to factor the expression. So 2 parentheses. And again, you want to find out what combination multiplies to be -6 and combines to be 1. So we know that 1 times -6, 2 times -3, and 3 times -2. So this combination works. So we have x plus 3 and x minus 2 divided by x. Now, nothing divides and becomes 1, so there's no holes. All right, now for the zeros, you set x plus 3 equal to 0 and x minus 2 equal to 0. So you subtract 3 from both sides, so x equals -3. Add 2 to both sides, x equals 2. Now remember, these are points, so that's -3, 0 and 2, 0. So let's graph those. So -3, 0 and 2, 0. All right, for the vertical asymptote, you set the denominator equal to 0, so x equals 0. So that's your vertical asymptote. So x equals 0. Okay. Now for the horizontal and slant asymptote, you do long division. So then we do x divided by 1x squared plus 1x minus 6. So you ask yourself, what do you multiply x by to give you x squared? Well, the answer to that is 1x. Now, you're not done with the quotient, so you have to continue. So 1x times x is 1x squared. 1x times... Oh, all right. So then there's nothing else to multiply, so then you subtract. That's 0. So then you bring down to 1x minus 6. Now you ask yourself, well, what do you multiply 1x to give you 1x? The answer is plus 1. So you have a slant asymptote at y equals 1x plus 1. Now remember, I'm going to divide this by 1, so we have our slope. So we start at positive 1, and then slope is go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. And then you go down 1 to the left 1, down 1 to the left 1. And you want to put every point you can, because it's a dashed line. So you can basically make the dashes every other point. All right. Now, in this case, we have our critical points because we need a point to know if the curve is above or below the horizontal asymptote. In this case, so our critical points we can use are our x-intercepts, so -3, 0, and 2, 0. Because critical points tell you where the curve is. So since the point's here, we know the curve is here and not here. And since the point is here, we know the curve is here and not here. Now, you probably won't get that lucky on every one of them, but in that case, we did. All right, so now let's take a look at example 2. Again, our step 1 is we want to factor the expression. So it looks like we can factor 2 from here. And so then we have x squared minus 1, which can be factored out to 2x minus 1, x plus 1. And then here, that can be factored out as x minus 2, x plus 2. All right, so nothing divides and becomes 1, so we have no holes. Okay, now for the zeros, we set the numerator equal to 0, so you have x minus 1 equal to 0, and x plus 1 equal to 0. So you add 1 to both sides, so you get x equals 1, so you have the point 1, 0. And here you subtract 1 from both sides, so you get x equals -1, and you have a point at -1, 0. So let's go ahead and graph those. So 1, 0, -1, 0. All right, for the vertical asymptote, we set the denominator equal to 0, so we have x minus 2 equal to 0. So we have x equals 2, and we set x plus 2 equal to 0. So we have x equals -2. So x equals 2. And x equals -2. All right, so now for the horizontal slant asymptote, we have x squared minus 4 divided by 2x squared minus 2. So here you ask yourself, well, what do you multiply x squared to give you 2x squared? The answer to that is 2. That completes the quotient. So we have a slant asymptote, or actually a horizontal asymptote, because there's no x, at y equals 2. Okay. Now this is where the work gets a little messy. Now we have to find critical points. Now here we need to find a critical point here. So I think probably -3 is probably good. Then we have to do a critical point at 0 and a critical point at 3. Okay, so first critical point is x equals -3. So we need to actually plug -3 in to the expression. So f of negative 3 equals 2 times negative 3 squared minus 2 divided by negative 3 squared minus 4. All right, so that gives you 3.2. So our first critical point is negative 3, 3.2. So we go negative 3, 1, 2, 3.2 is about here. And that's critical because that tells us the curve is here. Okay. So now we're going to do f of x equals 0. So we have f of 0 equals 2 times 0 squared minus 2 divided by 0 squared minus 4 equals 0.5. So then 0.5 is here. That tells us that the curve doesn't go above this. So our curve is here. Okay. And then our next is x equals 3. So we have f of 3 equals 2 times 3 squared minus 2 divided by 3 squared minus 4, which equals 3.2. Told you it's going to be messy. So then 3, 3.2, 1, 2, 3.2. So our curve is here. All right. So now let's take a look at, before I do, let me try to clean that up a little bit. Straighten that line up here, there, and there. And if some of you are like, well, I can't see that, let me try to zoom in real quick. There we go. So I'll give you a second to take a look at that if you had trouble seeing that. All right, now let's get back to the next example. All right, let's look at example 3. Sorry, adjusting some camera issues here. Wasting your time, and that's probably the best I can do. All right, so example 3. So, again, I'm going to factor the numerator and denominator, so that's x minus 1 divided by, really, just x squared. There's nothing really we can do. Okay, so nothing divides and becomes 1, so there's no holes. Okay, so now for the zeros, you set the numerator equal to 0, so x minus 1 equal to 0. Add 1 to both sides, x equals 1. So you have a 0 at 1, comma 0. Okay, so now for the vertical asymptote, we set the denominator equal to 0, so x squared equal to 0. Square root both sides, x equals 0. So you have a vertical asymptote at x equals 0. All right. Now for the horizontal slant asymptote, we do long division. So we have x squared divided by, now you want, it's x minus 1, but you need to actually have the 0x squared plus x minus 1. So, well, when you multiply x squared to give you 0x squared, the answer is 0. So you have a horizontal asymptote at y equals 0. All right. So now for the critical point, you need to pick a point on the left of the asymptote and the right. So looks like -1 is a good one, and probably 2. So let's look at first critical point, x equals -1. And I think we have more space because there's only 2 critical points here. There was a lot on the previous example, but this one only has 2, I think. So then that's, sorry, that was a horrible line. There you go, much better. All right, so f of -1 equals -1 minus 1 divided by -1 squared, which equals -2. So you have a critical point at -1, -2. So that tells you your curve is right here. Okay. So now our next critical point is, let's use, actually, 1 is actually fine. Oh, actually, no, because we already have a point at 1, 0, so let's do 2. So f of 2. So then that's 2 minus 1 divided by 2 squared equals 1/4, which is, we can just leave this 1/4. So our point is 2 1/4. So we go 2 up 1/4. And the reason we need that is because we need to know if the curve is going up or down. Since that point's going up, we know our curve is here. And it goes above the asymptote, which is a fascinating thing, and we should probably talk about in that class and talk about why that is. All right, so now let's look at example 4. Okay. Now, apparently I've used up some of the space for this problem, so I'm going to have to kind of branch off here. All right, so we'll have to do our factoring down here. All right, so 2 parentheses. So this is x and x. And the only combination that makes a +2 and -3 is -1 and -2. And here we can factor out an x. And so that leaves x minus 1. Now here you can see that this divides and becomes 1. So we have a whole, and we need to set x minus 1 equal to 0. So x equals 1. So now we need to find out what that point is. So we're going to substitute 1 into the original function except for this part. Okay, so it's actually just going to be, we're going to substitute 1 into x minus 2 divided by x. So that's f of 1 equals 1 minus 2 divided by 1, which equals -1. So you have a whole at 1, negative 1. So we go to the right 1, down 1, and there's a hole here. That's what we mean by a hole. Okay. Now for the zeros, we set the numerator equals 0, except for the hole. So we only set x minus 2 equal to 0. So that's x equals 2. So we have a point at 2, or 0 is at 2 comma 0. Okay. Since this divides and becomes 1, we still have the denominator at x, so we set x equal to 0. So we have a vertical asymptote at x equals 0. Okay. Now for the horizontal asymptote, slant asymptote, we do long division, so we have x squared. And really should put a 0x. Oh no. We have a minus x, sorry. X squared minus x plus 0. You really want to have every term divided by x squared minus 3x plus 2. So then you ask yourself, well, what do you multiply x squared to give you x squared? The answer is 1. So the quotient is completed. So we have a horizontal asymptote at y equals 1. Okay. Now, critical point, we already have a critical point here. That tells us the curve is here. So we already have that critical point at 2, 0. So now we need to know this side. And I would recommend negative 1. So when x is negative 1, we're going to substitute x equals negative 1 into the function. And we're not going to substitute, we're going to substitute it in without the x minus 1 part. So just the x minus 2 divided by x. Think. Actually, no. We can actually substitute into the whole thing. So f of negative 1 equals negative 1 squared minus 3 times negative 1 plus 2 divided by negative 1 squared minus a negative 1. So f of negative 1 equals that's 1 plus 3 is 4 plus 2 is 6. And then 1 plus 1 is 2. So 6 divided by 2 is 3. So our critical point is negative 1, 3. So that tells us our curve is above the asymptote here. So our curve is here. Wow, wasn't that fun? Probably useless, but lots of fun. All right, so at this point, you have two options. If you understood all the examples, start working on the assignment. If not, then you can ask questions about the examples or the assignment in class. And so you decide where you're at after watching those examples, and have a wonderful Wildcat day.